Hi, how are you?
Hi, nice to meet you. Doing well. How are you?
All is well, all is well. It's definitely an honor to meet you. I appreciate you taking out time to stop by on the platform. I'm really
Sure.
interested in hear about, some of the amazing things that you have done.
Okay, give me 1 second here to plug in my computer.
Okay.
Before we start, though, could you tell me just a bit about yourself? Like, how long have you been doing this? Where are you? What got you interested in the podcast?
Yeah, definitely. Um, about myself, I'm a world traveler. I've been to 70 countries. I'm currently in East Africa. I'm in
Wow,
Madagascar.
amazing.
Yeah,
You're in
yeah. So I
Madagascar? That's incredible.
Yeah, so I give you a heads up if we get disconnected, it's not as technologically advanced here. It's
Wow,
pre-recorded, so it'll keep
got it.
recording and then I'll come back in and then I'll edit it and the viewers won't notice or anything like that. I've been podcasting since 2021. Shortly after the lockdown, I was
Right,
bored. I was looking
got
for
it.
things to do and it was something that I really enjoyed doing, meeting new people, meeting
Right, right.
interesting and successful people, people that can teach me, people I can learn from. What was your other question?
I mean, that's about it. I just was curious. I mean, I Googled you, obviously, but that's amazing. You're in
Mhm.
Madagascar. It really stands out on the map, of intrigue. Like, it's just seems very exotic.
Yeah, it is. It's everything that they say it is. People very beautiful, very beautiful culture. It's like Afro Asian. I don't know. It's something that I never seen before. Like I said, I've been
Like,
all over the world, and they
are
got the
you
animals and the
yeah,
wildlife
like
too.
animals and stuff, and are you at a beach or like what is it like? Like a beach? Is it like summertime?
Yeah, it's hot. It's hot. I guess I'm in the north side of the island. They definitely got some real beautiful beaches, great food, very hospitable people, friendly people. It's one of the safest countries in Africa. It's like in the
Wow.
top five, I
Amazing,
believe.
yeah.
You
It's
know.
kind of like a world of its own in a way.
Yeah, definitely, definitely.
Helps me
It's just off the radar for a lot of people.
Yeah,
It get
off the
passed
radar,
over.
yeah, and it helps to be, an island, I guess, in that sense, like its history probably kept it separated.
Yeah, definitely, definitely. Now I can ask you now for the viewers who may not recognize you, let them know who you are, where you from, and definitely what do you do.
Hi, everybody. I'm Professor Sara Seager at the Massachusetts Institute of Technology. So I'm just across the river from Boston. Originally, I'm from Canada. I grew up in Toronto, and I spent about half my life there before I moved to the US, and now I'm a dual US Canadian citizen. And just so you
Wow.
know, yeah, I live in a town about 20 miles outside of Boston, and we take pride in being where the shot heard around the world came from, where the Revolutionary War started. And we're ramping up to celebrate the 250th anniversary of the start of the Revolutionary War this coming April. By the way, I don't know why I mentioned that. I was just sort of going through in my head, like we're on both sides because the loyalists, were the British and they moved to Canada after the Revolutionary War. So I kind of have a foot in both worlds.
Yeah, definitely. I'm glad you shared that because a lot of times people take history for granted, but it can be very, very empowering, and that's definitely something that needs to be remembered and celebrated. Now, when did you develop this passion for astrophysics and astronautics? Was this something that you loved as a child, or did you kind of get into it later in life?
A bit of both. I do think the sky is for everyone, and I hope you've seen the dark sky. You must have because you've been to 70 countries. You must have been in really dark areas. The stars, right? They're just so bright and it really is amazing. I always love the sky. One of my earliest memories is seeing the moon through a telescope. Wow. It's literally a whole other world. When I was 10 years old, we went on our first camping trip because my dad, he was from the UK. He was, believe it or not, there are people like him, he's not alive now, but like him who were like more comfortable wearing a tie on the weekend. And but camping just wasn't his thing, but he was a single dad. And our babysitter that summer insisted we all try camping. So this babysitter, like he brought his family stuff and we all drove to go camping. I think my dad never went camping again, where I got really into it. But when I was like 10 years old on this first trip in a dark sky and a moonless night, I stepped out of the tent in the middle of the night and I looked up and I was just, wow, just jaw dropping, astonished that there were that many stars. And I just remember being a child and was like, why didn't anyone tell me about this great thing? It was like as if you had never had ice cream. And then one day you have ice cream. You're like, why didn't anyone show this to me before? And it always stayed with me. Although, I went through like the teenage phase, I didn't really pay attention. But later in life, when I was a student in physics and later high school and undergrad, I realized that we can ask our own questions about the night sky and the objects in it. And we can find our own answers through like computer science and physics and telescopes. So in some ways it was destiny. And I was lucky I could find something that I love doing that I actually could get a paying job in. It's like the, crossroads of success.
Yes, definitely. That's very inspiring. Now I can ask you this. Now you actually teach. What kind of courses do you teach?
Well, during my time at MIT, I've taught a variety of classes for undergraduates. Right now, I'm teaching a class in exoplanets. It is a physics-based class in planets that orbit stars other than the sun. Every star is a sun. And if our sun has planets, it makes sense that the other stars have planets also, and they do. And astronomers have found thousands of planets, honestly, and there are all kinds of types of planets out there. We have not found any solar system copies. We instead find other kind of crazy systems. But anyway, you can write down basic physics and use some math like algebra, and you can describe all the different ways we find planets by their mass or their size or their brightness. And so in this class, believe it or not, there's so much research and work going on that we can derive everything and try to understand how planets are found, what they're made of, what they might actually look like. And that's the class I'm doing now. One of the favorite classes that I used to do in the past was called a design and build class. It's like for undergraduate students in their final year, they do like a project-based class. And we pick a project, like one of my projects was incubating an idea for a small satellite that ended up orbiting Earth. And the class, it's kind of interesting because it's really hard to apply what you know. Do you have that? Like you learn something on a book or from a lecture, and it's not really the same as the real world. So you can see these students, like the things are turning and they have to get materials, like build a circuit board or, some component. They have to work together in a team. And that's my favorite class, typically.
Oh, okay. Wow, that sounds very, very interesting. Now you had mentioned the courses that you teach now about the exoplanets, and have you seen a lot change in terms of, I guess, technology in the last, say, maybe the previous 10, 20 years and up till now?
So much change. I mean, the one analogy is the smartphone, which the large majority of people have compared to the old days with the flip. I don't know if you ever had a flip phone. Like there was a time when people didn't have cell phones at all. Then you had a flip phone. Now you have this great camera on your phone. Like the detector's getting better, computers getting faster. The technology has just changed so radically. And over time, we've also been able to get specialized telescopes to look for exoplanets instead of having like a general purpose telescope the community shares. So tons and tons of advancements have made the field possible.
Wow, that sounds amazing. Cause yeah, like you say, the average human, we've seen the television change. It was a big square, then it was real flat. The phones changed. So I'm just thinking like, in terms of what you studying, it had to be some tremendous
Yeah.
changes.
Well,
Now let me see.
the biggest change is really the detectors. Like, remember before we had film camera, people used to do photographic plates. They literally had plates attached to the telescope that would expose like your camera does. And now it's all digital, just like we went from film camera to digital cameras. It's the digital detectors that have made us get way more sensitivity in astronomy in general.
Wow. Okay. Okay. Now I can ask you this from your research. I guess what makes other planets so much different from Earth? Is it like a multitude of things? Like, is it a lot of things that make them different, or is it like in terms of being, I guess, habitable for humans or for life, or is it like a small number of common things? Like they don't have this, this, or this.
Yeah. Well, first of all, in the general sense, it's probably three things. Uh, well, maybe three or four. Think of like the planet mass. Like, how massive is it? The planet's size, how big is it? And its orbit, how far away is it from the star? So those three things probably do most of the controlling. But for example, the most common type of planet that appears to be out there, we don't have one in our solar system. It's a type of planet that's between the size of Earth and the size of Neptune. Our Neptune is 4 times the size of Earth. So we're kind of scratching our heads over here that the most common type of planet out there is one our solar system doesn't have. We don't know how it formed, and we don't really know what it's made of. And we have some contenders for it, like, is it, we hope it's something special, like a water world, a planet made of 50% or more mass that's water, like one of Jupiter's icy moons, but scaled up to be bigger. Or it could be like a massive rock with a giant envelope of hydrogen. So we're not really at the point of finding and studying habitable planets in detail, because our technology, even though it improved so much, it's still kind of not good enough. We're always more greedy, right? We want better pixels and more bandwidth and faster internet. So we're not quite at finding habitable worlds. So we're trying to, expand our minds and be like, could some of these exotic, smaller than Neptune planets that are very common, is there any way they could host life?
Wow. Okay. Now I can ask you, with so many planets being out there, is it any planet in particular that you found the most interesting, or is it kind of like, you've seen one, you've seen them all?
Okay. Oddly enough, we're not sure yet, and we hope to answer that question with real data from our new James Webb Space Telescope. The Webb telescope used to be called like Next Generation Telescope, like it's Hubble's successor. But we honestly are trying to answer that by looking at planet atmospheres. And we think the atmosphere can be like the tiebreaker between different ideas of what the planets are. But there is a favorite system. I'm going to try to explain it to you. And it does relate to habitable worlds, because although we can't find an Earth twin yet, we can't find like Earth 2.0, it's too small and too faint. We can find like an Earth cousin. So we can find planets that could host life, but they're not around a sun. Instead, they're easier to find. They're around a much smaller star, a star that's 1/10 the size of our sun. And there's these small red dwarf stars. They're honestly very common. I mean, it would be funny if there was life there and they'd be shaking their heads at like, there's something like Earth and it's around a sun and it's like so far from its star. But I want to tell you a tiny bit about these because they're the ones we can study today that we hope are habitable. I'm calling it an Earth cousin. So it's like, instead of you having your long lost identical twin out there, instead it's a cousin, maybe a different generation. They live in a different country and speak a different language. So it's not really anything like you. It's just not like Earth. It's different. So this star that we have in mind is called TRAPPIST-1. Just somebody named it after their telescope survey. And TRAPPIST-1 is a small star. It's 1/10 the size of our sun. Any smaller and colder, it wouldn't even be a star. It wouldn't be able to make its own energy. But TRAPPIST-1 has 7 planets. And these planets, because it's such a small star, it has very low energy output. So it's like the campfire analogy. To stay warm, if there's only a tiny fire, you have to stand right up against that fire. So the TRAPPIST-1 planets that are the right temperature for life as heated by their star, they're quite close to their star, actually. And this means also the closer it is to the star, the faster it goes around. So some of these planets that are in the habitable zone, their year, the time to go around, is only a few days. And furthermore, when the planet is so close to the star, due to tides, it gets into a very favorable energy stage where it's kind of complicated, but it rotates 1 time for every time it orbits. So it always shows the same face to the star at all times, just like our moon does to Earth. But what it means on that planet is one side is always in day and one side is always in night. And literally the star, the sun to any beings on that world, the sun is always in the same place in the sky at all times. Yeah, I mean, so it would never set or never rise. It's just like you would have to travel to like the far side of the planet to get darkness. And one other thing about these planets that's not as cute or interesting is that these small stars, they tend to give out a lot of flares and energy. So you might have like a lot of northern lights. It might be cool that way, but it could be bad as well because these high energy particles can be destructive for life. Or, you know how everyone's glued to their cell phone? You're glued to your phone. Because the high energy electronics would like be destroying your phone. And so it's just kind of a crazy type of planet. But that's what we have. That's the thing we can study today. And it's a little complicated to study them because their stars have a lot of spots and they're contaminating our investigations. But that's like a little glimpse into where we're at in terms of what type of habitable planets are in reach for us.
Okay, okay. Now, can I ask you this? Do you ever receive any backlash for this type of work or this type of research? You know, for several reasons, you know, people may feel one way or the other about it, or do you feel like most people are behind it and they're eager to find out, you know, what's on the new frontier?
Yeah, most people are eager. I mean, everyone loves science fiction, Star Wars, Star Trek, Interstellar. Like people love that science fiction is becoming science fact in terms of our work. But there are definitely a couple of groups that dislike it. Like often people say, why are we spending money on this? We have more important problems on Earth. And like nobody will disagree with that. We all agree. But at the same time, like as humans, we're just born to explore. And I do acknowledge it's like what you want to call a luxury job. There's just a small slice of money for this. But we want to explore and, we want to know what's out there. And there's also something hard to convey to people that, the really big discoveries, like for example, GPS, most people, how you go somewhere new because you're traveling to so many places. I don't know if this works in other countries, but you use your phone to like find your directions. Well, that's not something that just happened because someone said, hey, we need a navigation system. It just came from pure exploration. People tried to launch rockets just, cause. And eventually we launched rockets, we could get satellites, and then people made satellites have this navigation system for us. So it's a lot of money to invest in just, scientific exploration, but the outcomes that are found are like so huge, you couldn't get it in any other way. So there's that. We also do, I wouldn't say it's pushback, but we get an outsized interest from people who want to believe that aliens are here on Earth right now or believe there are UFOs. So it's not pushback in a way, but we get outsized attention from that group of people.
Okay, okay, I definitely understand. I'm glad you mentioned that about the GPS, yeah, because that's life changing. Because I can imagine if I tried to travel around the world, say 30 years ago or 40, however long ago it was without the GPS, that thing has came in handy. So I really appreciate those contributions that have been made by, the people in your field.
Yeah.
Let me see. Okay, I wanted to ask you about this. Now, you actually worked with NASA. You was a deputy science director for NASA Explorer. If you could just talk about that experience.
Sure. Well, I didn't work for NASA directly, but here at MIT at my university, we competed and won a competition to launch our own space telescope. And this space telescope it is still there. It's called TESS, like the girl's name TESS, TESS. Transiting Exoplanet Survey Satellite. And what TESS is it's 4 like glorified telephoto lenses, like 4 cameras bolted to a platform. And each aperture is only about that big. The whole lens is about this big. The whole telescope, like including, we call it like the heart and brains of the telescope, of the spacecraft. That would be like the computer and the data storage and like the batteries and solar panels. The whole thing is like 2 washing machines, 2 like American washing machines, like stacked on top of each other. So it's not very big. And it launched to space in the year 2018 on a SpaceX Falcon 9 rocket out of Cape Canaveral, Florida. And it has a really long elliptical orbit around Earth. And this mission stares at a giant patch of the sky. Like if you know the constellation Orion, it's like 4 Orions in a giant strip, just like stares at each patch for 1 month and looks at tens of thousands of stars at one time. We're playing like a numbers game. We're looking at as many stars as possible because some of these stars will have planets that are in a very specific orbit where the planet's going in front of the star as seen from our viewpoint. And we will see the starlight drop by a tiny characteristic amount every time it goes around. And it's kind of a long story about how we go from the little drop in brightness to planets. But my job as deputy science director was to make sure that we could find planet candidates and make them public for other astronomers to follow up to find exoplanets. So I had to I helped get the mission to win the competition at NASA. I helped like with budgeting, staffing, organization, computer codes, and software, and a whole bunch of other things to make it successful. So very exciting project that the telescope lives on. It's still orbiting, and it will orbit for a very long time.
Wow. Wow. I take my hat off to you and the team as well. Now, how
Thank you.
long does it take to, I guess, like you say, get funding and get the crew members and build something like that? How long do you have to invest? Is it a few weeks, a semester, a few years?
Yeah, it's many years. Like typically, because remember we talked before, we're not making a profit. So we can't just get investors' money and do something fast. Like in the business world, you'll have an idea and you have to get it to market. Because if you wait a decade, it's too late. Someone else came up with that idea and made all the money. But because we have less money, it can take a long time. You have to have a prototype and do like a demonstration. So this particular mission was about a bit over 10 years from concept to launch, which is short actually. 10 years is actually a short amount of time in space science. So between the competition and building some prototypes and testing them, it was about 10 years from concept to launch. It was not my idea. I was like number 4 on the project. So you have like, the principal, the lead, the deputy lead, and then I was like the 4th one, still very high, of course. But so that one took about 10 years, and it could operate easily for 10 years, for 20 years or longer. So these are long-term investments.
Okay. Okay. Wow. Let me see. It's about 9:57. Okay, I'll ask you about one more question.
Sure.
If you haven't talked about it already, the Starshade project.
I can definitely talk about Starshade. Let me see. Okay, I know you can edit this later, so just wait there for 1 second.
Okay.
Starshade is a giant specially shaped screen that would have its own spacecraft, and it would launch to outer space and work with the telescope. And the goal of Starshade is to block out the starlight so we can see the planet directly. Because stars are so bright compared to their planets, like our sun is 10 billion times brighter than our Earth. And no camera can take that picture. Like, have you ever tried to, I don't know if you've been to really cold countries or you're just into the warm places, but you know how when there's snow, you try to take a picture of your friends? You can't, because the snow is so bright, it overwhelms. So the Starshade it's a project that has been developed by NASA for quite a while. It was first conceived in the 1960s, and it sort of gets shelved and then revived continuously. But do you want to know why it's such a special shape?
Yeah,
Because
definitely.
you know what it is? If you block out a star, a point source with a giant circular screen, it ends up that you see ripples of light. You don't block it out. It's a crazy property of light. If you block out a point, actually you get ripples because the light can act like a wave, and it literally bends around the outer edges of a circular screen. It's like dropping a pebble in a pond, and you get ripples going outwards. Light acts like a wave and makes ripples. But if you have that special shape, it's designed mathematically so the light interacts with itself and cancels out. And it would be like dropping a pebble in a pond, except the pond would be perfectly smooth and all the waves pushed to the outer edges. So Starshade is a future space project. It doesn't have its full funding, but it's an idea that's very well developed. It's quite technically mature, and I'm a strong advocate for Starshade.
Wow. Okay. Okay. I really appreciate you breaking that down. That's very interesting. And like I say, I want to thank you so much for coming on the platform. I really enjoyed this conversation. I mean, you said so much, and it's how your mind works, you visualize and everything. So I'm still processing a lot of the stuff
Okay, right.
that you were explaining. I'm sure the viewers is enjoying it as well.
Thank you very much. It was great to be here today.
Yes, definitely. It's been an honor.